In this lesson, we're going to solve some 1- and 2-step linear equations. Here's our first example, solve for x. So I'm going to put a flowchart in here to help us with the steps we need for solving for a multi-step equation like this. So this one isn't a one-step, this one. What is the first step that you need to do here to solve for x? Solve for x means x needs to be isolated. I need to get rid of all these other numbers and just have x on the left side there. The first step is to collect the constants. That's just plain old numbers. 2/3 is not a constant. It's a coefficient because it's attached to an x. A constant is a number that doesn't have a letter with it. So what we want to do is take this constant, which is a 6. Oops, let me get a pen here. And I want to get this 6. That's a constant. I want to collect it with that 9 there. So how do I do that? I'm going to subtract 6 from both sides. Subtract 6 from this side, they will be gone, and subtract 6 from that side. And then we collect these two constants here. That gives us -2/3 equals 9 minus 6, and then we can just obviously do 9 subtract 6, which is 3. Okay, that's good. We've got all our constants collected. Now what do we need to do? The next step is to isolate the variable. Our variable again is an x. That's what solve for x means, isolate the variable. I've got a -2/3 attached to that variable. So we multiply or divide by the coefficient or the number attached to the letter. That's what a coefficient is. It's a number attached to the letter. So I'm just going to do this in steps here. I could get rid of that -2/3 all at once, but I'm just going to take it slowly. I'm first going to get rid of the denominator. I'm going to get rid of that 3. Right now, that is -2x divided by 3. So what's the opposite of dividing by 3? I have to perform the opposite operation. The opposite operation of dividing by 3 is multiplying by 3. So I'm going to multiply both sides by 3, and what we'll have then is this 3. Well, let me show you here. This is multiplying both sides by 3. So this 3 is going to cancel with that 3. That's why we multiplied both sides by 3 to get rid of the denominator. And then what we have left is -2x, that's this part that's left here, -2x, and then equals 9. So what's next? Well, we're not really done isolating the variable. We have to go back and look at that box again. We still have to continue on, multiply or divide by the coefficient. So my coefficient's now a -2. It was a -2/3, but I broke it up into smaller steps. Now it's a -2. How do I get rid of a coefficient of -2? I divide both sides by -2. So when I do that, when I divide by -2 here, -2 and -2, these -2's, -2 divided by -2 is 1. That will leave me with my single x all isolated. That's pretty much done there. The only other step, it's really those 2 steps that you see in the flowchart boxes here. These are really the 2 steps. But sometimes we have a fraction, and depending on what the question says, it might say state your answer as a decimal or state your answer as a fraction. So we're going to just reduce this. This is a improper fraction. I'm just going to change to a mixed fraction here, and that's therefore x equals -4.5. So this last piece here, this last box, we don't always have to do that. It's only if we have a fraction, and often this fraction, the improper fraction, is fine anyway. You don't even have to reduce it. You just have to see what the question asks of you. Okay, we're going to do a bunch of questions now. And I have our flowchart right here. Remember, this one here is kind of, we don't always have that one. These are our 2 steps. This is our 1 and 2 step. That's our title. Solve each of the following. 5 minus 3x equals 2. So let's look at the chart. First, we have to collect the constants. That means add and subtract numbers, not variables or coefficients, just numbers. So I'm going to, this is a constant and this is a constant. So I'm going to put them on the side that the x is not on because I want to get it away from the x, which means I'm going to have to subtract 5. Subtract 5 from both of them. 5 minus 5 is 0. So I'm still left with -3x. And then I have 2 minus 5, that's -3. So that's step 1. We collected our constants. Step 2 is isolate the variable. Our variable is an x, and in this case, I'm going to divide both sides. Go black here. I'm going to divide both sides by -3 so that they'll be gone. What do I have left here? X equals what? What's -3 divided by -3? It's +1. So there's our answer, and the last, that's our final line there. We don't need to do that extra box at the bottom. Part B, 4m minus 2 equals 4. First we collect the constants. That -2 is a constant, that 4 is a constant, that 4 is not. That's a coefficient. So I'm going to collect these two together by performing the opposite operation. I want to get rid of this -2 and move it over because I want to eventually isolate my m. So I need to get rid of that. I need to bring the -2 over to this side, and I do that by adding 2 to both sides. That leaves me with 4m equals 6. So there's step 1. Step 2, isolate the variable. Again, we are going to divide by the coefficient. Our coefficient is a 4. I'm trying to isolate m, remember? So divide both sides by 4. And we get m equals 6 over 4. Now we do have to go and look at that last box now. Reduce fractions if necessary. This can be reduced because I can divide both, they're both even numbers, so I can divide them both by a 2. So I'm going to get m equals 3 over 2. Or you could write it as 1 1/2. Okay, that's part B. Let's move on to C. So this one looks kind of messy because it's already, we're starting off with a fraction. Fractions, a lot of us don't like fractions. There's no reason for that. We still are going to follow the same steps. Step 1 is to collect constants. 4 is a constant, but this 2 is not because it's attached to the b, and this 5 is not because it's also together with the b. It's b divided by 5, so these are together. Constants don't have a letter attached to them in any way. So I can't do step 1, or it's already done. Let's look at step 2. Isolate the variable. Multiply or divide by the coefficient, which is the number attached to the letter. I have a 2/5 here. I'm going to do them in steps like I did on the previous slide. So I'm first going to get rid of this denominator of 5. The way I do that, because this is right now to be divided by 5, the opposite of that would be to multiply by 5. So I'm going to multiply both sides by 5. So 2b over 5 times 5 and 5 times 4. These two cancel each other out, and I'm left with 2b equals 20. So now we're still on the second step here, isolate the variable. We're still trying to isolate b. I'm going to divide both sides by 2 because the b and the 2 are attached with multiplication. The opposite of multiplication is division, so I have to divide, and that gives me b equals 10. D. This one is weird looking. Okay, step 1, collect the constants. This -1 is a constant. This 3 is not a constant. It's attached to that. So I don't have a step 1. I'm going to go right to step 2. Isolate the variable. Multiply or divide by the coefficient. So I've got a negative in front of the t, and I've got a 3 denominator. First thing I want to do is get rid of the 3 denominator. Since this is t divided by 3, the opposite of dividing by 3 is multiplying by 3. So I'm going to do it right up here on the question line. I'm going to multiply by 3 on this side, and I'm going to multiply by 3 on this side. So 3 times -1 is -3 equals, these two cancel out, and I have a negative t. Now how do I get rid of a negative in front of a t? Basically what that is, that's an invisible -1 there. So I'm going to divide both sides by -1 to isolate it, and to get 3 equals t. Next one for part A, 3x over 4 equals -2. Okay, collect constants, same thing again. There's only the -2 constant, the 3 and the 4 are not constants, so we don't have this step. We only have one step to do. Isolate the variable. So maybe now is a good time for you to press pause and do this yourself. I will, and then when you come back, press play and you can skip through if you want to. So press pause here and try this one yourself. Okay, let me do it with you. I need to get rid of the denominator 4, so I'm going to multiply both sides by 4. This side times 4. Remember, a dot means multiplication. This side times 4. These 4's cancel out. I get 3x equals 8. And then I am still trying to isolate the variable. This is 3 times x, so I have to divide by 3. Instead of x times 3, I have to do the opposite operation, which is division. And that gives me x, oh, that should be blue, x equals 8 over 3, or, oh, that was a negative 2, sorry, that was a negative 2. So that's a negative 8 over 3. The last step here, reduce fractions if necessary. Again, that depends on what the question is saying. So this could be a final answer here, or your final answer might be as a mixed fraction. That would be x equals negative 2 2/3. Now over to part B, solve for the unknown. All right, let's look at our steps. We've got 2 to do for part B here. Solve for the unknown. Step 1, collect constants. Do we have? We do, finally. The 4 is a constant, it's a positive 4, and 7 is a constant. Now, how do you decide how to put them together? So you want to get them away from the variable, because I want a to be isolated. My bottom line, at the very bottom down here, I should have a equals some number, right? So I want the a all alone. So I want to get the 4 away from the a. So I leave the 7 where it is and I move the 4 instead. What I'm going to do is subtract 4, because right now we're adding 4, we subtract 4 from both sides. Let's try this orange color here. Get negative 2/3 a. 4 minus 4 is 0 equals 3. Next step, we have a fraction. We're going to get rid of the denominator first. Instead of dividing by 3, I need to do the opposite of that, which is multiply by 3. So I'm going to multiply both sides by 3, and I will draw that in right here. I'm going to take this side and I'm going to multiply it by 3, and I have to take the right side and multiply it by 3. These 3's cancel out, and I now have negative 2a equals 9. Now we still are on step 2, which is isolate the variable. I have to get a all alone. Remember, this is my goal down here, just an a. I have to get rid of the negative 2, and because the negative 2 is attached to the a with multiplication, that's really negative 2 times a right there. I have to do the opposite of multiplying by negative 2, which is dividing by negative 2. And that gives me 1 here. They cancel out, and I have a final answer of a equals negative 9 over 2, or back down to step 3, if necessary, we could reduce it, or turn to a mixed fraction, negative 4.5. If you're having a hard time when I'm going from a mixed fraction to, from an improper fraction to a mixed fraction, like in this question, or this question, or this question, then you need to go and look at videos on that. That's not something I'm going to cover here, is how to go from improper to mixed. So that's something you'll have to look up if you're getting confused by that, because if the question does tell you the final answer, if it says to state answers in mixed fractions, you're going to have to know how to do that. Number 2, solve for the unknown. Same thing every time. My unknown is a k, which means I want k all alone. That's my ultimate goal. I want k all alone. First, collect constants. Add or subtract numbers. Positive 1 is a constant and positive 6 is a constant. So I want to collect those. I'm going to collect them by bringing the 1 over with the 6. I want to get that 1 away from the k, from the equal, the side of the equal sign that has a k on it. Subtract 1 from both sides. That gives me 5 equals k over 2. I want to isolate k. I'm on step 2 now. How do I get rid of k divided by 2? What's the opposite of k divided by 2? That would be times 2. So I'm going to multiply this side by 2, and I'm going to multiply this side by 2. This gives me 10 equals, and these turn into a 1, 10 equals k. So there's my answer. If you like to have your letter first, you can just swap them both around, and you can write k equals 10. It's the same thing. Our last question, the only difference here we've got is it says solve and check. So I'm going to solve it just like I have before, but I'm going to do this one extra thing here. Okay, collect constants. I've got a 3 that's a constant because it has no letter with it, and I have a 7 that is a constant. How do I decide where to collect them? Where do I bring them together? They should be on the opposite side of the equal sign that the m is on. So the m is here on the left side of the equal sign. So the 3's got to come over with the 7. So I want to pick up the 3 and I want to move it over here, but I mean on the other side of the equal sign. I'm moving it to the other side. The way I do that is I subtract 3 from the constants. Now I have negative 4/5 m equals 4. Now I'm on step 2, isolate the variable. We've done this several times now. To get rid of the denominator of 5 there, I'm going to multiply both sides by 5. They cancel out. Now you only do this when it's a coefficient, when it's part of the m. I now have negative 4m equals 20. And my last step is still step 2, isolate the variable, multiply or divide. I'm going to divide this time. To break off that negative 4, it's attached to the m. I have to divide. Negative 4. That gives me m equals negative 5. So now we're going to check. To check, we create a little t-chart. First I'm going to write out the question. I'll put it right here. This is the question again here is 3 minus 4/5 m equals 7. And then I'm going to draw you would use your ruler, a t-chart through that, a horizontal and a vertical line into a chart. This side is my left side. This is the left side. Left side is 3 minus 4/5 m. Right side is 7. My right side's really easy. The right side, that's all just a 7. My left side's a little harder. My left side is 3 minus 4/5 m. Since m is negative 5, that's what I'm checking. I'm checking to see if my answer is right. So I'm going to put a negative 5 in for this m right here. 3 minus 4/5 times, and in for m, I'm putting the answer I got, which was in red there. It's a negative 5. Oops, that should be purple. Negative 5. So that's 3. Now, negative 5, and these 5s will cancel. Notice I have 2 negative signs here. Those 2 negatives are going to make a positive, and the 5's canceled, so I have a positive, and now all that's left there is a 4. That gives me a 7. And my right side was also a 7. If you get your left side and your right side to equal each other, it means your answer is right. It doesn't mean the answer is 7, not at all. All it means is you balanced both sides of your equation. They both balanced to equal 7. But that balancing only happens when m is negative 5. So this is the correct answer here. Therefore, we know we are right. M equals negative 5. So that is how you do 1- and 2-step equations, and they're not too tough. If you are able to follow this chart and all these questions here, you were able to do them, or if you just watched, then now what I think you should do is write down the questions themselves and just try them, and you have a whole page of answers here and you can see if you got them right.